Hello, welcome back to Cracking the Cryptic. We've got a wonderful Sudoku hunt coming up on the 1st of June by Blobs. That's coming up on Patreon, so do join us on Patreon. There's loads of content on Patreon, including, at the moment, Simon solving a rock-hard Fist-and-a-Fell puzzle called Skyscraper. It is a Sudoku, and it is monstrous. Today's puzzle might be monstrous. It's by Math Pesto. I'm a bit nervous about that. Math Pesto, long-time friend of the channel, has been sending us puzzles for ages, contributing to apps and Sudoku hunts and all sorts. And I'm a big fan of his puzzles. They're always very interesting. This puzzle features modifiers. Anyway, those apps, they're all available on the links under the video too. Only some of them have Math Pesto in, but all of them are good value and great opportunities to improve your Sudoku skills. Also under the video, Sven's Sudoku pad and our merchandise, which is all great stuff too. And we are streaming on Tuesdays or Wednesdays every week at the moment, so yeah, that'll be coming out, I think, on Wednesday. Is that today? This week? It depends when this video goes up. I'm not sure. No, I think it's still to come. I'm losing track of time. Monday's a bank holiday. That's the problem. Anyway, we are going to have a go at this, and I'm going to go through the rules now. It's called Plus or Minus 1 by Math Pesto, and normal Sudoku rules apply. 1 to 9 go in every row, every column, and every 3 by 3 box. Values, not digits, along a purple line comprise a set of non-repeating but consecutive numbers in any order. So we could have 5, 3, 2, 4 on that line. A black dot joins two values in a 1 to 2 ratio. There is exactly one knapp daneben cell in each row, column, and box. So 9 modifiers, 1 in each row, column, and box. A digit in a knapp daneben cell has its value either increased or decreased by exactly 1. E.g., a 3 has a value of either 2 or 4. Each digit appears in a knapp daneben cell exactly once. However, it's possible for 2 digits to become modified to the same value, such as both 5 and 7 becoming 6. It's a simple rule set. There's no given digits in the puzzle. There's no way of telling how difficult it is except by reading the name of the constructor, Math Pesto. That's telling me that it's pretty difficult. The video length will be telling you another, probably, confirmation of that, or possibly refutation of it, or indeed uncertainty. Anyway, I'm going to have a go at the puzzle now. Let's get cracking. So. Apologies if my pronunciation of knapp daneben is wrong. I am not a German speaker. Right, well this has... No, I was going to say this has 1 to 9 on it, but of course it has the values. The values of this... Oh, this is an 11 cell. Right, that's... Sorry, I thought it was a 9 cell trapezium. No, that is not a 9 cell trapezium, but this is an 11 cell one. Let's focus on that. Now, that's great. That's great. It tells us straight away that the values on it must be from 0 to 10, because they're the only values you can achieve under this rule set. Now, there are 2 knapp daneben cells on it. One of them is a 1 that has a value of 0. One of them is a 9 that has a value of 10. The fact that there are 2 knapp daneben cells on this means that these cells in rows 8 and 9 are natural, and these cells in row 7, because there must be 1 knapp daneben cell there and 1 here. And that uses up any possibility of having values outside the set of 1 to 9, because they've both been used up here. The 1 and 9 on the modifier cells has been used up there. So I'm planning to use red for knapp daneben cells and green for non-ones. I'm trying to learn something from the black dot arrangement here, not really getting it. This one, I mean, we've got the normal 1, 2, 2, 4, 4, 8 and 3, 6 combinations possible, but also 10, 5. But actually we haven't got the 1, 2 one possible. Oh yeah, we have. We have, because there could be a, in fact there is. Okay, and now I'm beginning to see that as well as the 1 and 9 that appear in these cells, we have each of the digits from 1 to 9. Ah, okay, that's useful. So we have a 1 in these cells that represents 0, but we must also have a number that represents 1. And because the two modifier cells are 1 and 9, all of the numbers from 1 to 9 are represented by their own digit. So therefore we have two 1s in these cells, and in exactly the same way we have two 9s. And now I know that these three cells are 1, 9, and a modifier cell. And the values of the 1 and 9 here are 1 and 9. Now, 9 cannot go on the black dot, can it? No, it can't, because it would go with a value of 18 or 4.5. That is not allowed by the rule set. So that's a 9. There's our first digit, 3 minutes. Very happy with that. There is a value of 1 on this and a modifier cell. Now, the value of 1 has to go with a value of 2. The modifier cell can't be a 1 being doubled to 2 because we've had the modified 1, so it's a 3 being reduced to 2. And the modifier cell is a 3. The modifier cells here are 1 and 9, and we've used up some of the possibles. Now, this is also, of course, a purple line, and we've got values of 1 and 2 on it. These other values must be 3 and 4. So this, well, I don't know what digits we can put on there, because we could have an increased 2 or a reduced 5. But this has a value of 3 or 4. And this cell, therefore, has a value of 6, 8, or 2. How am I going to show these values? I don't know. I'm just going to have to keep it in my head. That's really annoying. And this has a value of 1 or 2. We can't have a 10, 5 outside this black dot, because this is the only, this shape is the only use of a value of 10 in the puzzle. So these are going to have to be selected from 1, 2, 3, 4, 6, and 8. Now, this cell has a value of 1 or 2. I was about to say there must be a 3, 6 black dot, but I don't think that's necessarily true, because we could have two values of 2 in the same column, or 1. Oh, we've got a 9 on this line with its own value. Therefore, the other cells on the line have values of 4, 5, 6, 7, and 8, because we can't go outside the Sudoku digit sphere for values except on that bottom shape. 3, 4, 5, 6, 7, and 8. I was going to say the 3 is genuine, but there might not be a digit 3 on it. It is weird. I mean, I know I've used this particular type of modifier before, but I don't think I learned any long-lasting lessons from doing that, and it's still messing with my head quite badly. These had a value of 3 and 4. I was going to say, does that mean this has values of 5, 6, 7, 8, 9? No, because you couldn't have repeat values. You just can't have repeat digits. I might be able to put 1 there. 1 can't go on this line because its values are from 3 to 9. If 1 went on this line, it would be a genuine 1. The values on the line they would have to they would be 1, 2, 3, 4, 5. We can't go outside the set. And that must be a problem with these, even allowing for doppy values. It is, because the only digits you could use to get values of 1 to 5 are 1 to 6. And these are also from the digits of 1 to 6, and that would be 7 of the digits from 1 to 6, and that doesn't have a concept. So this is a 1, and that means this is a 3, and is the knapp cell, isn't it? It is, yeah. There it is. Okay, so these all go green. That's a 1. That can't be a digit 3 for what it's worth. Now the digit 2, I don't think that can, maybe it could be. With a value of 3, maybe it could be on that shape. There's no digit 1 on the black dots, but that's not necessarily very helpful. Two to 8 on this line. Values, 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 values. This has a value of 3 or 4. This has a value of 6 or 8. Now that means, it doesn't mean that we know any of the values on this line. Where is the 9 in this box? That's quite interesting. The 9 in this box is now on this shape. It might have a value of 8, but it's on this shape. It doesn't have a value of 8 because the funky 9 is in this box. So it has a value of 9 and it's on the shape. The shape therefore has the values of 9, 8, 7, 6, 5. And that means that the 2 and 3 in the box are in this row. The 2's in one of those cells. I'm talking about the digits now. The 3's in one of those two. This can't be a 2. It can't be a 2 with a value of 2. This shape, didn't we work out that its digits, the values on it, they are 3, 4, 5, 6, 7, 8. Right, on this line we have values of 1, oh, I've been saying that has a value of 2. Yes, that's from the black dot. And therefore these have a value of 3 and 4. This one, this one's a green cell, so that's a 4 now. This has a value of 3. So it's either a genuine 3, quite likely, or an increased 2, possible. So it has a value of 3. This has a value of 6. And is not a 9. 9, 8, 7, 6, 5 are the values here. This is now a 2, 3 pair of digits. Because 3 has to be in one of these cells, I think. Or was it? How did I know that? Because we've already had the funky 3. But this could be a funky 2. Okay. So the value of this is 3. It's either the increased 2 or a genuine 3. We've already had the funky 3. It's a genuine 3 or an increased 2. So the value of that is 3. So the value of these cells are 4, 5, 6, 7, 8. Is that any use? It almost isn't. I think this is a 3. What's on this line? There are the funky 1, the funky 9, and 9 ordinary digits of those numbers. So there's only one 3 in that group of cells, but this group of cells needs 2 3s in it. So that's a 3. Now there's an ordinary 3 in these cells somewhere. One, 4, 3. That has a value of 6. I am going to just put that up there, and this has a value of 3. It's difficult to use these. I don't know. I don't want to use those. I want to remember that that has a value of 6 and a value of 3. This has a value of 3 as well. These both have a value of 3. So one of them is clearly the knapp daneben cell. Therefore, these are all genuinely giving the right values of 9, 8, 7, 6, 5. And they are, well, I mean, I suppose it's been obvious for a moment, actually, if I'd thought about it, that they are genuinely the digits. 5, 6, 7, 8, 9. This one's on a black dot. It can't be 9, 7, or 5. That is a 6 or an 8. This has a value of 3 or 4. Yeah, we can't go up. Just checking. It has a value of 3 or 4. But it could be a funky cell. Well, could it? It could. But we've got the funky 2 here. We've got a funky 1 and 9 on this shape. We've got a funky 2 there and a funky 3 here. If that was funky, the funky 2, with a value of 4, no, with a value of 3, sorry. Oh, this is a genuine 6, because it has a value of 6. Oh, that's huge. That's 8, right. Just need to do this sensibly. That's a 9. This now has a value of 4. And it can't be a funky 3. So it's either a 4 or a funky 5. And there's a 9 in one of these cells, and it is a genuine 9. So the values on this triangle are 9, 8, 7. That is a genuine cell, so it's 7 or 8. And here, well, what could give values of 9, 8, and 7 if we can't use 6 and 8? Only 9 and 7. Now, it might be a funky 7, but then the genuine value of 7 would be impossible here. So therefore, it is a pair of genuine cells that are a 9-7 pair, and that's an 8. And one of these two is funky. Now, there's a 3 in this column, a digit 3 in this column, and it's there. And that is non-funky, that is green. This one is the knapp daneben 2. 7, 9, 8, 6, 3, 1. Down here we have 2 and either 4 or 5. No, we now know this is funky in this column. It's the last cell that can be. So that's a 5 masquerading as a 4. And that takes 5 out of those cells. So that's a 5-7 pair. This is a 6-8 pair. I'm pretty happy with this progress, I'm not going to lie. And that's a 2-6 pair. And this is fulfilled. This is fulfilled. All these black dots are fulfilled. This, the jobby, is not. And now I've just discovered, well, I think I've got a problem now. No, I haven't got a problem. I was trying to find a place to put a 3 on this line, but I've already got a value of 3 on the line. So these are genuine 4, 5, 6, 7, 8. I can green those because I've got the red there. Actually, that principle lets me green all those because of this red. Now, this must include a 4. And these are genuine cells in the range 4 to 8. So they are selected from 5, 6, 7, 8. 1 and 9 are out here somewhere. That cannot be a genuine 9 because we can't put 4.5 or 18 there. If it was a genuine 1, this would be a genuine 2. Yeah, I don't see how I'm ruling that out yet. These include a 4 and something from 5, 6, 7, 8. It's odd that I've had no more truck with this line since it gave me the break-in. That's really weird to me. But I suppose probably not really that surprising if I'd thought about it, which I hadn't. Okay, I'm going to have to think about this 1 and 9. I was planning to go somewhere else, but there's not many other places to go, annoyingly. I have a feeling this line is going to be very difficult if that was a 1. Because we've had the funky 2 and 3, as well as the funky 1. So any values in the range 1 or 2 have to be genuinely attested. So if this was a 1, that would be a 2 and a genuine 1. And then where does a genuine 2 go on this line? Impossible, because that sees all the cells. So that is not a funky 1. This is a 1-9 pair of digits and values. That's really interesting for this thing. Now, this cell is 5, 6, 7, or 8. We can't put 5 or 7 on a black dot. Except down here, possibly we could put a 5 because we could get the 10 value down there. But here we can't. So that's 6 or 8. The value of this cell is 3 or 4. So I don't see how that can be a genuine 9. It can't. It's a 1. That's a 9. The values here are 2, 3, and 4. 2 has to be represented by a genuine 2 because both red 2 and 3 have gone. This is a value of 3 or 4. And this line, is that more helpful? It feels less helpful now than this one. This has values of 2, 3, 4 on it. So this cell, well, values though. It's got a genuine 2. It might have a funky 4, giving a value of 3, but then it couldn't have a real 4. So it doesn't have that. It has a genuine 2 and a genuine 3 on it. And it can't have a funky 5, giving a value of 4, because the funky 5 has gone, giving a value of 4, funnily enough. So this has a genuine 2, 3, 4 on it. I think that conclusion was sound. That digit can't be 2, because it's either a genuine 3 or a genuine 4. Okay. Now, 1, 2, 3, 4, 9. This cell, well, it is 5, 6, or 7 by Sudoku, looking at digits. It can't have a value of 5 or 7. And it can't be a funky 5. So I'm going to rule out 5. Therefore, this is either a genuine 6, but that would need a value of 3 here. And that's impossible. Or a 7 with a value of 6, but that would need a 3 here. So that's impossible. So it's a 7 and a funky 1, but its value goes up. Its value is 8, and the cell there is a 4. And that is a green cell, a red cell, sorry, in the middle of nowhere. So we can colour a lot of greens from it. And we've had the red 1 and 9 are down here. 2, 3, 5, 7 are gone. Red 6 is not going to be here because there's a 6 there. So there's a red 4 or 8 here, a red 6 or 8 up here, and a red 4, 6 or 8 up here. That was fascinating, but not ultimately very helpful. That's 5 or 6 by Sudoku. That's 5 or 8. Now, what's going on this line? Not 5 and 8 genuine, because that would have to be a 6. So one of these is a 6. If the other one is an 8, that has to be a 7, or at least a value of 7. If the other one is a 5, this has a value of 7 or of 4. Oh, sorry, that 7 is looking across here if I actually look at what it's doing. And that 5 looks back here, and now we get digits filled in a go-go. That's a 4. Right, now we need a value of 7 here, and we can't do it with an actual 7. So this is a funky 6 or 8. It's definitely funky, but I don't know which of those digits it is, because we still have 4, 6. Oh yes, I do. I've got a 6 there, so it's a funky 8. Excellent. And then we get a bit more greenage. I have discovered green again, my lord. Okay, these are from 2, 3, and 9. There's a funky 6 up here because we only got 6 and 4 to place in these two boxes, and we've got that 4. So the funky 6 is in one of those two cells, and I get more greenage, more green acreage, which is appropriate. There's a funky 4 somewhere up here, and that's an X-wing with 4 down here, and that must be a 4 now. The only place for 4 in column 6, basically. Now the funky 4 is going to have a value of 3 or 5. So, well, it won't have a value of 5 on the black dot. Oh, 8 is in this. That's a 5, 6, 7 triple. These include a 1 and either 2 or 3. Now, we've got, on this line, we need a 4 and an 8 here. They're genuine, good, because we've got a 3 value, 5, 6, 7, 9. So that has to be 4 and 8 to make up the gaps. This is 2 or 6. Right, this is going quite well. I'm really enjoying it and not finding it quite as vicious as I rather expected. Now the value of 6 on this triangle, or rather the digit 6, is going to have a value of 5 or 7. Now we have the same problem. We cannot run through the number 6. In the values on this triangle, we can't run through the values of 6 because after we've put the funky 6 in it, we can't do another funky digit, and therefore we have to have genuine values, and we can't put another 6 on the line. Therefore, we have to run either down from a funky 6, being a 5, but we can't do that because it would go through 4. So we have to run up from a 6 acting as a 7, and also put 8 and 9 here. And the 8 by Sudoku is going there in what now is a green cell. So this is the funky 6 cell, and this is a 9, and that triangle makes sense now. And we get a little bit more green acreage, not a lot. But we also know that these cells, which do have a funky cell in it, don't have a funky 9, so they have a funky 1. And there's a funky 9 acting as a 10 in one of these cells, but it can still be on the black dot. Now, the 1 that we're placing there as a digit puts a 1 in one of these cells. In fact, these seem to be a 1-2 pair by Sudoku, which is going to help down here. We get 6 there, 1 in the corner. Take 6 out of those cells. Let's look at this column actually. 8, 6, 2, 3, 1. That one is 5 or 7, which forms a pair, and 4 and 9 are down here. 6, 3, 1, 4, 9. Oh, bother, something has gone badly wrong because I didn't get an 8 down here. Okay, I did that wrong when I was filling in the final column. I put a 6 there, and that was fine. This is an 8, not a 1. I'm sorry, don't know how I did that, but let's fix it. Now, let's see if I can still make this a 5 or 7. Yes, I can, which is part of a pair. This is a 4-9 pair. Okay, this is better. What a relief. 4, 9, 8, 3, 6. Actually, let's use the 8 for Sudoku. And put a 6 there. Right, 4, 9, 6, 3, 8. Now, these are from 3, 5, 7. In fact, there's a 5 sitting there, isn't there? So I can place 5, 7, and 3 in the box. That 7 makes this a 5. These cells now are 1, 2, and 7, and the 1 is funky. 3 and 4 are looking across at that. 9 is looking at that cell. Now, this has got a funky 4 on it. And that 4 represents either 3 or 6 as a value. And what's it touching? Hang on, the 4, what did I just say? I think I said the wrong thing. The 4 can't represent a 5 as a value. Yeah, now that these can't have the funky cell, that's when this happened, right. There is a funky 4 up here. Actually, that does a little bit of Sudoku first, but there's a funky 4 here. It can't have the value of 5 on the black dot because we can't have a 10 that's not down in these boxes. So the 4 has a value of 3, and the other digit here is a 6, and that seems to work fine. So this is a 4-6 pair where the 4 is cheating as a 3. So that does a bit of Sudoku as well. 1 in the corner. I thought we had 1 in the corner before. That was when I got it wrong in that corner. This is a 5. These cells are 1, 3, 7, and these are 2, 8, 9. And can I do this zigzag line now? I don't think I can put 8 or 9 there on a cell with a 4 on it. So I'm going to put 2 there. This can't be a 7. We need a 3 value. Oh, but this is, I don't think this can be a 6 value. So it has to be the 3 value. And then this is a genuine 1. There we go. This goes green and is a 6. This is lovely. I mean, this, I can see this on the verge of finishing. That sees a 2 and an 8. 1. Odd that I haven't done those. This can't be a 5. That can't be a 6. This can't be a 5. That's been so for a little while. Didn't notice. We're not finished now. But we got red, so almost our last bit of green acreage goes down there. Also 4 is looking down there. So was 8 looking down there. I just didn't see it looking. Now, there is a cheating value here. Now, what digits? Oh, we've only got 1 and 9, and one of these is a 9, valued as a 10, of course. So this is now a 9-5 pair, and the 9 is funky. And that's going to do a lot of Sudoku. So let's do the Sudoku first of all. Finish column 4 rather first. Then maybe we can do column 5. It does look good. And quickly column 8 while we were there, or box 6 rather. That's a 6, that's a 5. This is all just filling in. This is marvelous. Right. What are we going to get down here? We're going to get... that we can't have a 3 here, so that's 3 in the corner of the box at least. That's 2 or 7, but down here we have 1 and 6, and they are resolved by this. So 1, 6, that's now a digit 1, and I think 1 was the funky digit over here, wasn't it? It was, thank you. So that's funky and that's funky. And that's going to be our last disambiguator, because this funky one is the funky 9, and that's a 5. The knapp danebens are all done. I finally returned their official names rather than my own coinage of funkiness. Now, oh yes, I thought I had deadly patterns. I absolutely don't. I have just a few 7s and 2s to tidy up. And that is plus or minus 1. Plyness, we used to call that. I don't know if that term still exists. I haven't heard it in many years. But that is a very clever puzzle, most enjoyable and remarkably, I think, approachable. 30 minutes on the solve. I mean, I think I did a decent solve for once. I've recorded some puzzles lately where I really didn't, but that was good and that was great fun. And as always, I am incredibly grateful to Math Pesto for providing us with such fantastic puzzles, like all the constructors on the channel, frankly. There's never a bogus one or a duff one, is there? It's brilliant. Thank you for watching. It's you guys who bring the joy all the time, and we are very grateful. Apologies to the Germans for my pronunciation, but also not. And we'll see you again soon. Thank you for watching. Bye.